Our Contacts app is shaping up quite nicely, but as you might have already realized, it's hard to find a contact in our list because they're not really sorted in any manner. Over the next few videos, let's sort our contacts alphabetically, with each alphabet being its own section. In doing so, you will understand how to use sections to organize the data in your table views. We're going to keep things pretty simple and just sort on the first letter in the user's first name or on the contact's first name. The actual Contacts app on your iPhone allows you to sort by either first name or last name, and then depending on your choice, it reorganizes all the contacts. Now, the first thing we need to do is to make it really easy to query each contact for the first letter of their first name so that we can use that to sort. Right now, we'd have to do that manually when we iterate through each contact. So instead, let's create a computed property in an extension. Now, I'm going to add all this extra logic in the contact list controller file at the very top, since all of these additions are for the sake of organizing this specific table view. So right after the import statement, we'll say extension, not that one, extension contact. So I'm going to give this property that I'm adding a really obvious name. So we'll say var first letter for sort, and this is a string. Inside, we're going to get the array of characters for the first name property. So that's first name dot characters. And then we're going to grab the very first character by using the first property, since characters is just an array. And since we know that the first name is always going to exist, I'm going to use a bang operator because this is an optional property. Now, we want to return this, the very first character, but we want to return it as a string. So we'll use the initializer on the string type to create a string literal out of a character. And now we can return it. Now, we're also going to use this property to display section titles. So let's go ahead and return the uppercase variant so that we can easily use it. Okay, so now we have an easy way to get an uppercased first letter for each contact, which we can use to sort. The next step is to get an array of all the first letters for all the contacts we have, and then to sort those. For example, if we have contacts Alice, Susan, Mark, and Zoe, we want the letters A, S, M, and Z, and then we want to sort them so that the final array is in alphabetical order, A, M, S, and Z. We have to take one small thing into account. We have more than one contact with the same first letter. So let's say our contacts list was something as follows: Alice, Alicia, Alan, Ben, Amit, and Nick. When we put together a list of first letters to use as sections and then sort the contacts, we don't want that list to be A, B, A, N. We just need to know how many unique first letters are there in our data set. All the names starting with A will be sorted into a single section named A. So our list should just be A, B, and N. So what we're trying to do now is just get that list of unique first letters. This will allow us to figure out how many sections we need and how we should sort our data. Now, complicated as that sounds, it's fairly easy to implement. So let's create an extension to the contact source type. So extension contact source. Since this is where our data is stored, we'll manipulate the data here to get it into sections. We're going to add a static computed property to the type that returns this list of unique sorted first letters. So static var sorted unique first letters, and this is going to be an array of strings. The reason it's static is because the contacts property, the underlying data on this type, is also a static property, and we don't want to worry about creating instances for any of this. So first, we're going to get a list of all the first letters for all the contacts in the contacts data. This is a simple line of code. So let first letters equal, so contacts is the underlying data source, and we're going to map over this array and pass in a closure that just takes the first letter for sort from each contact and creates a new array out of it. Now, the big thing is we need to get rid of duplicates. So there are many A's in here. We need to get all of that down into one A. We could iterate over this array, keep track of the letters, and perform some logic, but there is a type that handles this for us already, the set type. A set is an unordered collection of unique elements. You use a set instead of an array when you need to test efficiently for membership, and when you aren't concerned with the order of the elements in the collection. Basically, when you need to ensure that each element appears only once in a collection. It doesn't matter the order. This is exactly what we want to do. Now, sets in Swift can be initialized using arrays. So we can say let unique first letters. This is really simple. We'll just say set first letters. And just like that, we have a unique list of first letters. But remember, this is unordered since sets don't care about the order, but we do, because we're going to convert this back to an array and use it to show our contacts alphabetically. So just like sets can be initialized with arrays, we can do the reverse as well. So we'll say return an array that's made up of the elements of this set, sorted. Now we have a list of unique first letters, sorted, that we can use to create our sections. There are different ways you can structure sections. One is to use a dictionary pairing, where each key returns an array as a value to use as the data for that particular section. In our case, for example, with the key A, we'd get an array of contacts whose first names start with A. We're going to keep it simple as always and create an array of arrays for the section data. This array will be ordered in the same way as the array of unique letters. For example, in the first nested array in the section data, all the names will be starting with the letter A. So how do we create this? As always, it's far simpler in code than when I try to explain this. So let's add another static computed property to contact source, and we'll call this sectioned contacts. And the type here is going to be an array of contact. So nested arrays, basically. And what's this error that we have here? Undeclared type contact. Yeah, we're going to ignore that. Okay. So inside this property, we are going to map over the array of sorted unique first letters to get each of those letters to work with. So we'll say let sections equal sorted unique first letters dot map. And this is a closure, so we'll assign that value that's passed in, the argument and name. We'll say first letter in, and open the body of the closure. So here we're basically grabbing each letter out of this unique first letters array and doing something with it. So once we have the first letter, we're going to use that next to iterate over all the contacts in the data source. Then we're going to filter out those contacts that begin with the first letter. So here we'll say let filtered contacts equal, so the underlying data is contacts, dot filter. And this takes a closure, and here we have to provide a Boolean expression. So we'll say $0, which is the argument passed in from the filter method, dot first letter for sort. So what's being passed in here is a contact, since this is an array of contacts. So we'll check that the first letter for sort equals the first letter being passed in as an argument from the map function on the outer closure. Basically, if this first letter is A, we're going to go through the contacts and get every contact that starts with the letter A and assign it to filtered contacts. So here now we have an array of contacts that start with letter A. The next iteration will be B and so on. Now, this array of contacts is not sorted though, so we're going to sort it and return it. So assume again that right now we have just a bunch of different contacts whose first names start with A. We're going to say return filtered contacts dot sort by or sorted by. Again, this takes a closure, and we're going to say $0 dot first name is less than $1 dot first name. The sorted by function takes a closure and provides the first two values in this array as an argument. So we're saying that the first value, $0, should always be less than the second. Since these are strings, that means they will be sorted alphabetically. And as we go through the entire array, every time we iterate over it, we'll get a sorted array in the end. Now, we then return this resulting array, and in this way, when we iterate over every first letter and create an array for each pairing of letter, we'll end up with an array of arrays containing the sorted data inside this sections constant, so we can just go ahead and return from here. We now have the section data that we want to work with. So how do we communicate all of this new information to the table view though? Well, let's figure it out in the next video.